Welcome back to week 3, and this week we've been able to do a couple of new things in creating lines, and we done the direct line method, which we had to utilize ortho in the status bar, and we also got into polar coordinates, and that's whenever we had the length of the line and the angle, and we're able to use that data to draw in a line at a certain degree of an angle. Now we're going to go in and we're going to draw a land boundary in a survey type setting, and it's a little different, but it's not so much different than what we did with polar coordinates. It's kind of using the same method, it's just using a different type of direction. Now when you work in the civil and surveying fields, you're either going to be working far as direction either with a azimuth or a bearing. Now they're distinctly different in how you go about getting a direction, and I want to show you what the difference is. Really, in AutoCAD it's better to use the bearing because it's already set in its memory. It's kind of already set up that way when you use this method. And well, first let's show you what a bearing is. Now, we all understand what north, east, south, and west is. Alright? It's like you're standing right here in the center of this compass, and if you're standing and looking due north, that's what we call due north. If you're standing here looking due south, you're going due south and east and west as well. Now with a quadrant, it's just like the word says, quadrant. You're splitting this 360 degree circle up 4 times perfectly, and when you do that, 360 divided by 4 will equal 90 degrees. So in between here you've got 90 degrees in between these 4 quadrants. Now what are these 4 quadrants, you say? Well, you're just looking at it between north to east. This would be my northeast quadrant. Between south and east, this would be my southeast, my southwest, and my northwest. Alright, now each one of those quadrants have 90 degrees inside of them. Now always remember that when you're figuring out this degrees, always remember, go from the poles. It'll always be northeast or northwest or southeast or southwest. You never start from east and go north. You don't have a west-south. It's always going to go from your poles and go toward that direction. So on this one, on bearings, you always start at the poles, and it'll always be 0. So north here would be 0, and down here would be 90 toward the east. So if we had a line, for instance, and we were starting right here, and we're walking this direction here, right about there, this line would be north 60 degrees east. Alright, if we had us another line, and we were going to slide through here, that would be around north 75 degrees east. Okay? Now, let's say for instance we were walking in this direction. Again, you come from your pole, so this would be 0, and it goes up to 90, which would be at the east. So this will be south 15 degrees east, and so on and so forth. You kind of get the idea now. If you had a line here going this direction, it would be south 75 degrees west. Now this is a bearing. This is how it's set up. Now an azimuth is a little bit different. Azimuth starts up here at north 0 and goes all the way around 360 degrees. That's the difference. It's just one complete 360 degree circle from the center point where you're at, as opposed to a bearing being in quadrants. So with that information, just to remind you of that information, we're going to get in and we're going to start drawing this little boundary that we have. And let me bring that up, and it's right here, Project 3. I want to minimize that so I can bring that over here and kind of look at it a little bit. And I want to zoom in And you can see here, this is my POB, my point of beginning, and it's north 84 degrees, 21 minutes and 54 seconds east. Okay, so again, we look at it north 84, 21. So it'd be like north, we'll just kind of eyeball here, be about somewhere in this direction here. Alright? And if you go back and look at it, you can kind of see that angle that it's on. So I want to minimize this just a little bit too so I can see both of them at the same time. And so we're going from here, going north 84, 21, 54 degrees east at 100 foot to point 2, which is a tree. And then we're moving on at south 89, 21, 55 east at 185 feet. So I want to couple this just for an example for you. And I want to hit new on this on my AutoCAD, and we're going to set this up in engineering. Now, if you're utilizing AutoCAD by itself, you can use the engineering and it'll draw it exactly to scale. But sometimes people use surveying CAD or Carlson, and when you use that, sometimes you have to use the decimal unit. That way it can convert back and forth to one another. It just depends on what you're doing. But if you're not converting back and forth with another software, just use the engineering and hit next. And on this one, I want to use surveyor units, and I want to put it down to degrees, minutes, and seconds. I'm going to leave all this alone. I'm not going to touch that. And then I'll set my limits at 1,000 foot, 1,000 foot, and hit finish. So let's come up on here. I always type in Z for zoom when I start a new drawing, especially when it has large limits, and I hit A for all. It shows all my limits. And on this one, I'm going to start out with a line, and I'm just going to just type in 0, 0 just to start out with. Just give me a good start point, because I don't have any specified point to go off of. And I'm going to type this in, just like your polar coordinates. I want to hit at. I want to type in 100 foot, put my angle sign in. You all can see that down there in my command line. And now I want to hit my bearing in. You hit N for north, type in 84, and hit D for degrees. Then type in 21, type in minutes, and then type in 40 or 54 seconds, and then put E for east. Now make sure that you all see this and jot that down before you start, and that helps you to see how this thing should be wrote out. So at puts this at 0, 0, and then 100 foot, angle, north, 84, D for degrees, 21 minutes, 54 seconds, east, and just hit enter. And we'll zoom in there, and there's that line. There's the first line. Now the second line, I'm going to hit add again, and 185 foot angle, and I'm going to type in S for south, and 89 D for degrees, 21 minutes and 55 seconds, E for east, and hit enter. Then it shoots it down through there. So you guys got a pretty good idea of how this is going with those two just little samples. But I want to also show you how to put points in here, just like how this has got number 2 points. Come up here and make sure you got your menu bar open here. You go to Format, come down to Point Style, and come in here and click on this point and set it to absolute units and hit OK. And when you do that, come in here to points, draw, point, and you can slide in here and click on it and zoom in. It's really small, so we'll have to go back and fix that. Hit Format and do Point Style and absolute units. We'll have to change this. We'll change it to like 25 and just see what that looks like. Okay, makes it pretty big. Still needs to be a little bit bigger. We're just eyeballing this. Let's go to 40 and hit OK. Looks pretty good. And where those points are, you just put those on there, and then you can add some text a little bit later on when we get to that text side of it. So now, also I want to put some dimensions in on this thing. I come back up here to annotate. I will set this to annotative, and I want to come down here, and instead of using these architectural scales, I want to use a civil scale. And mostly in civil or surveying, you're going to have 1 inch equals 50 foot, 1 inch equals 100 foot. So I don't have any of them, so I want to go custom, and I want to make myself some. Hit add and say 1 inch equals, let's say we'll try 50 foot and see what that looks like. And make sure right here, this is just the name of it, but down here it's important. So this would be 1 inch right there, and this right here would be 50 foot, and hit OK on that. See how it made it for us? Now, with that annotative on, I would come down here and do 1 inch equals 50 foot, and I'm hoping this is going to turn out okay if I do an alignment on it. And again, that's in inches, so I'll come back up here to dimensions in the annotative, the dimension box, and I want to change that to modify primary units. I want to be in engineering, and you see how this is on here, it's got the arrows and things. If you'll look over here, it doesn't have all that. You can actually go to lines, and you can suppress that and that, where you just have these numbers only. Suppress. And we also need to turn it in symbols and arrows. In text, we want to align it with the dimension. And just hit OK on that, close, and you can see now, and that 1 inch equals 50 foot might have been to not the exact right scale, but we can put that right underneath of it. And up here at the top, we need to put that north, again, that degree in. And to do that, just to check yourself to see if you're all right, what I always do is just hit line here and put you a line vertically. And this is coming from the northeast, so I should be able to do an angular measurement. And it says it's 84 degrees. Well, the problem of it is I need to go into degrees, minutes, and seconds. So again, I come back up to annotate, and I go back to my dimension style right there, modify, and inside of primary units, I slide down here to unit degrees. It should be degrees, minutes, seconds, and I want to go to the degree, minute, second unit, and on that I close it, and you can see right here it's 84 degrees, 21 minutes, and 54 seconds. And I can take this now, and that's all one piece. I can move it, but it's going to hang right with this, with that degree movement there. All you have to do to get that broken loose from this is go back to your home tab and hit explode. And now when I click on it, I can move it. And I'm just going to take that ortho off. I can move it anywhere I want to. And if you want to take and go even further with that, you can click on it, come up here to rotate, and it asks you down here to specify a base point. I'll hit right here in the center. I'm going to turn off my object snap, catch it right here in the center, and kind of rotate it around and get it where you want it at, and bring it on in. And you can rotate it and clean it up a little bit better. Again, come up here to rotate, catch the center, and get it dead on the money. just like that. And then if you want to add in that north and east on it, double click it, and then just come over here, north, caps lock north, and east, just like that, and you'll have it done. And again, come over here if you want to add in those dimensions like that, linear, aligned. Catch that point. You got that in there. And I always like to take this and do a angular measurement. You got it in right there. Click on it again. Come up here and explode it. Grab this and do a rotate on it. And then if you grab that grip, you can take and move it. And we might have to do this a little bit more of a rotation on it. And double click it. And you can come over here and then type in your south and your east. And you do that all the way around this thing. So it's not too bad. It's a lot of small steps involved with this, but it's really not that bad to type in. But if you have any questions, please contact me.